Yeah, so here I am with a scrap part from another job in the lathe. I didn't scrap it, somebody did. And I'm modifying it to use on the back of the index mill. And the purpose is to provide a thrust plate for a tie rod assembly that I'm putting in the index mill. We had an issue with the way the mill head was mounted, and this tie rod assembly is kind of a belt and suspenders approach to solving that problem. We made a new part for the front end, but because it was so badly damaged, we assumed that it needed a little bit more support than it had. So this tie rod is threaded into the casting, which mounts the head to the overarm, and this thrust plate is on the other end of the tie rod, so I can put a load on it and kind of clamp everything together. So here we are with a piece that's about 6 inches in diameter on the outside diameter. I've already done some work on this and did an original fit. I don't know why I didn't video it, but I didn't. So you see the smaller diameter is just under 4 inches in diameter, and I'm going to go down to that. That diameter gives me about 1/8 of an inch clearance on the hole on the end of the on the end of the overarm to fit in the hole. So it gives me 1/8 of an inch play, so things can be lined up as necessary. And as you see, the machining of this goes pretty easy. I'm surprised. It's 304 stainless. I thought my little 10F would have a lot more trouble with it than it did, but it went all right. Right here I'm running at about 165 RPM. And you'll notice that with I've got it in a 4-jaw chuck, but you'll notice that I'm also pushing on it with the tailstock and a ball bearing mounted chuck to give it some additional support so it doesn't come loose from the 4-jaw. Here we are finishing this off, the last couple of cuts, and we'll do this, of course, and then I'll take a file to clean up the edges. This is the last cut. Found I was able to take about 20 thousandths per pass on these throughout the operation, and that was pretty much all the machine had. You hear a little bit of chatter there because I'm taking a fairly wide cut. I'll go back in and clean it up just a little bit. The Atlas 10F lathe is a 1937, 1938 vintage machine. This particular one has Babbitt bearings and has power cross feed, but it does not have quick change gearbox on it. Works okay. Just don't be in a hurry to do anything. Doing a facing operation here to do the last little bit of cleanup on that. It's not really critical. I could leave that rough, but because it's not a sealing surface, there's no gaskets that go under there or anything. It's metal to metal contact with a little pin in between. I was surprised this 304 stainless machined as well as it did in here. And there we have it. We're starting with a piece of 2-inch diameter B7 all thread, and I'm turning the outside diameter down to I think it's 1 3/8. A lot of that diameter gets removed just by removing the threads, so we fairly quickly get down near the target size. Center drilling and end drilling. Drilling and tapping for a 1/4 inch, 20 threads per inch thread. Final part isn't that thick, but I'm drilling extra deep so I can thread as far as I can. This tap is giving me trouble. You'll see in a minute I'll switch to a different tap. Yeah, right there I'm using a new tap. And that other one got sent to the recycling bin. Chippering the corners. This particular process I'm setting up to cut a groove. It's actually an O-ring groove. I'll show you the dimensions in a minute. I'll have it written out on a piece of paper. The intent is to have the edge of the groove 1/16 of an inch from that face. Here I'm writing down the dimensions. As you can see, I've got a couple of dial indicators set up. As you can tell, my videography needs a little bit of help. I'll be making some changes in my current setup to fix some of that. Changing speed here, slow it down so that I don't get that chatter. The D7 all thread is fairly hard material, so I started having some issues with the part moving in the chuck. I didn't realize it right away. You'll hear it right now where it's intermittent cutting. And that's the point where the part moved in the chuck. I'm trying it again, but you hear it. You can see it moving in the video too. It's no longer on center. Turns out that the issue was that the threads were not strong enough to hold the part on center as I was trying to cut it. I've done it that way in the past on some things, but this particular piece I just didn't like it, so I'm turning a spot so that I can grip it, and I'm going to put it in a 4-jaw chuck. So now I've got it down to a clean surface. I'm going to take that out. I'm holding it in that small chuck because the part's still hot and I don't want to burn my fingers, and I didn't want to wait for it to cool down. And I'm just pushing that into the chuck to make sure it stays put. I did get the run out down to about 1/1000th of an inch. Fortunately, when I ran into the issue with the part coming loose in the chuck, I was not near full depth on the O-ring groove, so I was able to just go back and finish the groove. I didn't have to remake the part. There's a trial fit. About a couple thousandths loose, which is exactly what I was looking for. So that's a real nice fit for that. I cut the part away from the slug that was holding onto, and I'm doing a face and turn operation here to clean things up. Facing operation here, and then I'll be putting a chamfer on that. Not a turning operation. I misspoke. Since I put that chamfer in there, I've got to go back and check to make sure the threads are okay. And they're not. But they are now. Or they will be in a minute. There we go with the final installation here. I don't have it in view here, but I'm putting the O-ring on and I'm putting some lithium grease on it. And now to put a socket head cap screw in there, a very short one in there. It's basically being used as a plug. And we're done. We'll move on now to the next.